Okay, anybody have any homework questions or any MP3 since there's not too many people here today? If not, I think I only have online homework for the complex numbers, is that right? Okay. Alright, so I want to start section 2.5, and we're going back to factoring polynomials, finding roots, and all that good stuff. I think these are only printed one-sided, so you have some room on the back of the handout if you need it. And we're going to go back to this idea of starting with a polynomial function and then using Desnos to find the rational roots where it crosses the x-axis, and then doing long division to find the other factors. And it might be the case that the other factors from long division actually lead to complex roots instead of just real roots. So there's not a whole lot different in this section. The methods are the same. There's a little bit of new terminology, but that's about it. Okay, so example 1. I'm going to make sure I have a good marker too. Okay, so example 1 is going to be to let f of x be 5x cubed plus 15x squared plus 45x minus 65. And then part A says find all roots of f of x. And then part B, once we have all the roots, we'll be able to write it in a root form really easily. Okay, so the first thing I have to do is, before I can find all the roots, I have to use Desmos and find the rational roots. So, let me get the projector going. I'm going to enter this, while I'm waiting for the projector to catch up, I'll type the polynomial into Desmos. 5x cubed plus 15x squared plus 45x minus 65. Okay. So I plotted this into Desmos, and I tried to look all over the place, all over the x-axis, and it turns out that this function only crosses the x-axis at x equals 1. Okay, so the only rational root, turns out to be the only real root this time, is x equals. Okay, and actually that's not going to work because the camera won't pick up that far to the left. I'll write it right here. The only rational root is x equals. Okay, so from the graph you just get one rational root. Okay. Now anybody remember how this went before? So if there's only one rational root, does anyone remember how to get a factor in the root form that we're going to divide into the function? Anybody remember how to do that? Okay, let me remind you. Here's the root form. Okay, so that's the root form. Once I know the roots R1, R2, and R all the way up through Rn, that gives me factors of the polynomial. So if I know x equals 1 is a root, That implies x minus 1 is a factor. Okay. And if it's a factor, that means x minus 1 divides f of x. Not divided, divides. Okay. So from the graph on Desmos, the only rational root is 1. That tells me x minus 1 is a factor, and therefore it has to divide the polynomial. So now what you'd be working on is using long division. Ashley. So we are starting section 2.5, which is about finding complex roots of polynomial functions. So if you were here for section 2.3, it's basically the same thing, where you have to use Desmos to find rational roots. That gives you factors of polynomials, and then you use long division to find the missing factors. So we're just working on example 1 right now. I am recording the class session today, so I'll just post the video on, I'll post it on Canvas as an announcement once I get it extracted and uploaded. Okay, so just again, let me go over that one more time. If I take a polynomial and I want to find all the roots and find the root form or factor, what I did was I went and I graphed this polynomial on Desmos, and it only crossed the x-axis at x equals 1. That means x minus 1 is a factor, and if something is a factor, that means it has to divide the polynomial. So now I'm going to use long division and divide x minus 1 into the polynomial. So how does this little game work? So hopefully people got a start on this. So what's the first thing I ask myself is, what do I have to multiply x by to get the first term, 5x cubed? And would that be a 5x squared? And then you're going to take 5x squared and distribute it to x and negative 1. 5x squared times x is 5x cubed. 5x squared times negative 1 is minus 5x squared. Okay. Okay, and then now what do? You subtract down. So 5x cubed minus 5x cubed is 0. 15 minus a negative 5, it becomes addition, and you'll get 20x squared. And there's nothing to take away from the last two terms, these just drop down. So when I subtract the top polynomial, when I subtract the bottom one from the top one, I get 20x squared plus 45x minus 65. And then now I'm going to repeat the process. So now again, what do I have to multiply x by to get 20x squared? That's going to be a plus 20x. And then I will take that result of 20x, multiply it by x minus 1, and get 20x squared minus 20x. And then I will subtract again. 20x squared minus 20x squared is 0. 45 minus a negative 20 becomes plus. You'll get 65x, and then the 65 comes down, or the minus 65 comes down. Now I play the game one more time. What do I have to multiply x by to get 65x? Just a positive 65. Take 65 and multiply it by x minus 1. I'll get 65x minus 65, and when you subtract, you get a remainder of 0, which is what you should get. Okay. So I'm gonna start writing this in root form. what this now implies is that f of x is the product of x minus 1 and your quotient. So the first factor gives me the rational root of positive 1, and then the other factor might give me the other two roots. And let me just simplify that a little bit. All three of these terms have a 5 that can be factored out to the front. That's just your leading coefficient. Five times, is it 13 gives me 65? I believe that's right. So we're going to learn these terms later. I have done, this is factoring f somewhat. I factored f in the product of a linear factor, and this is what's called an irreducible quadratic. And we're going to see this term again later. Okay. It's called an irreducible quadratic because it has no rational roots. Okay. So I'll pause there for a second. Now, how do I know it doesn't have any rational roots? So what was the very first thing I did when I started this problem? Come back over here. How did I find that the only rational root was 1? We went and looked at the graph on Desmos. Okay, it only had one rational root, or that was the only rational root. And if it was a multiplicity 3, notice the degree was 3 up here. If this was a repeated root, my other factor would have just been an x minus 1 to some power. Okay. So that was the only rational root that was given by Desmos. And if it was a repeated root, I would have more than just one x minus 1 showing up. Okay. So now, to find the other two roots, what am I going to do? Probably quadratic formula. Okay, so to find the other two roots, we're going to solve. We're going to take this quadratic factor and set it equal to 0. Okay. Now you can use completing the square to solve this too. I'm just going to use the quadratic formula, but you could use completing the square. Okay, so x is going to equal, so I'll just write down the formula again, plus or minus, negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, a is 1, b is 4, and c is 13. Okay, so I'll plug this in. It's minus 4 plus or minus the square root of 4 squared minus 4 times 1 times 13 all over 2. And you can do the rest of this in your calculator. One root's going to be given by taking the plus. The other root's going to be found by doing negative 4 minus the radical. Let's see. 4 times 13 is 52. 16 minus 52 negative 36. So this ends up being negative 4 plus or minus the square root of negative 36 over 2. And this is why we spent that time with complex numbers. Anybody remember? How do I write the square root of negative 36 in terms of I? The square root of negative 1 is I. Actually, I'll just do this, sorry. So the square root of negative 1 is I, and the square root of 36 is 6. So this will be negative 4 plus or minus 6I over 2. And you're going to get two roots out of this. Negative 4 divided by 2 is going to be the real part. And one of them is going to be plus 3I, and the other root is negative 2 minus 3I. These are the other two roots. So, one thing I want to point out at the top of the page, there's the fundamental theorem of algebra. It says every nth degree polynomial with real coefficients has at least one complex root. It's going to turn out that every polynomial of degree n has n complex roots. So what did you notice? This is a polynomial of degree 3. And how many roots were there? One real root and two imaginary roots. So it has one real root, but two imaginary. So that was part A. So now I have all the roots. One root, the rational one is 1. And then you have negative 2 plus or minus 3I. Okay. So next thing I'm going to do is I'm going to use that and write this f of x in root form. Let me get rid of this. Okay, so part B says write f of x in root form. Okay, there's the general root form. Remember, a is just the leading coefficient of 5. We already knew our first factor was x minus 1. And this will look funny, but this is what it's going to be. So my second factor is going to be x minus, or my second and third factor are going to be x minus each of those roots. Okay. So this is your root form. Now, did I really do anything new technically from section 2.3? It's the same method. Given a polynomial, if you want to put it in root form, you have to be given the rational roots or find them with Desmos. Once you find the rational root, you take the corresponding factor and use long division to find the other, in this case, quadratic factor. And then if I wanted the other roots and wanted to put it into root form, I had to use the quadratic formula. That gave me the other two roots, which gave me these two missing factors. Okay. Now part C. Part C says to plot those roots in the complex plane. So I'll just remind you what the roots were. The roots were, they still are. X equals 1, negative 2 plus 3i, and negative 2 minus 3i. Okay. Let me point something out to you about your handout. So it says plot the roots of f in the complex plane. That's not, it shouldn't be labeled x and y, okay, because this is the complex plane. So really you can cross off the y and the x. And what you're going to instead write is the imaginary axis and the real axis. Remember, there is a difference between the xy plane and the complex plane. And I think I can go 3 units in each direction to get by on this one. Okay, so if I want to plot these 3 roots in the complex plane, where's x equals 1 going to go? So remember, every complex number, which includes real numbers, has 2 parts. A real part and an imaginary part. So x equals 1, the real part is 1. What's the imaginary part if there's no I? What do you think? What do you think, Tracy?
0?
Yeah, it'd just be 0. So if I'm going to plot x equals 1, it's kind of like thinking of it as 1 plus 0i. So you're going to go 1 unit to the right along the real axis, but up 0. So there's x equals 1, right there. So it only lives on the real axis because there's no imaginary part. Okay. And then how would I plot negative 2 plus 3i? Just like I'm plotting a point. Starting at the origin, I go 2 to the left, and then I go up 3. So there is x equals negative 2 plus 3i. And then negative 2 minus 3i is go left 2 and down 3. So here's x equals negative 2 minus 3i. Okay. Questions on that one? Okay, now I think I mentioned this. Yesterday. Complex roots come in conjugate pairs. So remember from yesterday, a plus bi and a minus bi are conjugates. So they're the same complex number, it's just the sign in the middle or the sign on the imaginary part's been changed. So these two are conjugate. Okay. So at the top of the next page there's a theorem. It says complex roots occur in pairs. So if a plus bi is a root, its conjugate is automatically a root. Okay. So now I can actually give you complex roots and you'll be able to find some of the other ones. So example 2. What I say is if I and 2 minus I are roots of a 4th degree polynomial with real number coefficients, and say I know that f of 0 equals 10. Part A says find the other 2 roots and write f in root form. Okay. So, since x equals I, which is, can I think of I as 0 plus I? Is that okay with everybody? And x equals 2 minus I are roots. I claim I get 2 other ones for free. So again, that theorem says complex roots come in conjugate pairs. So what and what are also roots? So what would be the conjugate of I, or if you consider it 0 plus I?
Negative I.
Just minus I? Okay. Right, or 0 minus I, which is this minus I. So that's a root for free. And then what would the other root be? If 2 minus I is a root, what would its conjugate be? Just 2 plus I? You're just changing the sign on the imaginary part. By the way, Ashley, I don't know if you're here, you saw it. I is the square root of negative 1. So we're okay, so I've got the other 2 roots. There's 4 of them. This is a degree 4 polynomial. Just gotta check. Hopefully I'm still recording. Okay, so now say I want to write this in root form. So the roots are I, minus I, 2 plus I, and 2 minus I are the roots. So now, you're going to start writing the root form. There's a leading coefficient. So the first factor in the root form, you'd get a factor of x minus I. What's the second factor going to be that comes from the root minus I? Okay, plus, because x minus, if you subtract a negative, it becomes a positive. Okay. And then you have x minus 2 plus I and x minus 2 minus I. Alright, so now I actually have to show you how to multiply these factors together. What I'm going to, before I find A, right, I'm going to have to use the f of 0 equals 10 to find A. I'm actually going to multiply all this up first. So I'm going to multiply this together first. I'm going to come off to the side to do this. So this is going to accomplish 2 things for me. One, this basically is the root form once I find A and substitute it in. But also part B, if you've looked ahead, is going to be to find the standard form, and I would have to multiply that all out anyways. So let's do these. I'm going to multiply these 2 first. This will be easier. So I'm going to multiply the first 2 and the last 2. And then I'll have to multiply the results from both of those. So you can just, by the way, anybody notice these are conjugates? So you only have to multiply the first 2 terms. You're going to get x squared. Remember, if you multiply conjugate, what happens to the middle and outer terms? You're going to get a minus ix and a plus ix. So now I just have to do minus I times I, which is minus I squared. So here's another thing we did yesterday. If I is the square root of negative 1, what did we see I squared was?
Negative 1.
Just be a minus 1, right? Okay. So I'm really subtracting negative 1, and I get x squared plus 1. Okay, now I have to multiply these 2 together. Now, I'm going to do this a little differently. I guess everybody see how I've got like an inner set of parentheses and an outer set of parentheses? I'm just going to go ahead and there is a shortcut to this if you get really good at it. Like, I'm going to write down what it is. And then let me see if I do this times this. It's 4 plus 1, it's 5. That's what it ends up being. Now let me show you how I do that. Okay. Now this is a little bit tedious. Actually, I'll do it right underneath here. Okay. So if I was going to do this and I was going to multiply this out all the way, again, here's kind of the trick that I used. So the first one's easy. X times x is x squared. Okay. Actually, this might be easy too. 2 minus 2 plus I times 2 minus I. 2 times 2 is 4. I times minus I is positive 1. 4 plus 1 is 5. Where did my minus 4x come from? Well, I get a minus 2x, and I get another minus 2x, which gives me a minus 4x. If you do enough of these, you'll be able to see how to just write it down right away. If you're unsure, though, you can distribute the negatives. So distribute the negative to the 2 plus I and this negative to the 2 minus I. Only thing that sucks when you do this is each one of those sets of parentheses has 3 terms, so you're going to get 9 terms after you multiply this out. Okay, so I'm going to take x times all 3 of these. You'll get x squared minus 2x plus ix. So I took this x times all 3. I can't draw all the arrows or it's going to get ridiculous. And then I have to take negative 2 times all 3. Minus 2x plus 4. And then a negative 2 times I is a minus 2i. And then I have to take minus I times all 3 of these. Minus ix. Minus I times minus 2 is a plus 2i. And then minus I times plus I is a minus I squared. And you're actually going to get a lot of cancellation. I'll pause for a second. Okay. So you get a little bit of cancellation. Ix cancels with the minus ix. You have a plus 2i and a minus 2i. And then, is it okay if I stop here? You have an x squared term. Minus 2x is the minus 4x. And then what's minus I squared, really? This guy right here is really just a plus 1. Because you're subtracting negative 1. 4 plus 1 is 5. So I've done enough of these to kind of just see what's going to happen each time. Okay. So now, and again, yes, this is a little tedious, but now this equals a times x squared plus 1 times x squared minus 4x plus 5. Now I have to multiply these together. Okay, I'm going to get rid of this. this because I'm out of room. Okay, so f of x is a times, now we're going to multiply these two out. So I'm going to take x squared times all three and 1 times all three. You're going to get x to the 4th minus 4x cubed plus 5x squared, and then 1 times all three of those. This leaves you with the same thing. So I did x squared times these three terms, and I got x to the 4th minus 4x cubed plus 5x squared. Then I took 1 times all three. And then I think we can clean this up a little bit. This would be x to the 4th minus 4x cubed. 5x squared plus x squared is a 6x squared minus 4x plus 5. So this is kind of tedious. So on the test, I often do not have you find the standard form, unless it's not so bad, but most of the time I just have you find the root form. Okay. So I'm almost there. I basically have the standard form. If I knew what a was, I would just distribute it through for standard form, and I could just plug it in up here to get the root form. So now I have to use, I haven't used this yet. Okay, so I have to use the f of 0 equals 10 part. So how does that work? What does this mean again? So I'm saying when x is equal to 0, I plug it into this expression, and what am I supposed to get back as a result? 10. Okay, so now f of 0 equals 10 implies that. So what do I get if I plug 0 into this part? Are you just going to get the 5? 5 times a. So the left side just becomes 5a, and that's